Thank you everybody for joining us today. We are here for Sketchulation tutorial for new beginners, part 5. My name is Natalie C, and I'm a structural engineer at Tipping Structural Engineers. Joining me is Mike. Mike 𝗱𝗲𝗃 is a principal at Tipping. He's been with us for about 20 years. Today we are going to be talking about charting. One of the best features of Sketchulation. It gives us an opportunity to better communicate our results. Mike is going to be reviewing through a series of examples. Just as a reminder, before we go into our review of our session from 3 weeks ago, I just want to let you know that our tutorials are all live on YouTube. I think most of you have received announcements from me with links to all of these tutorials. So please reference them and feel free to message us on the forum if you have any questions. I think most of you have my email and Mike's email as well. So as we begin, we're going to do a review of part 4. I've added colors to my slides, so it's a little easier for you guys to follow. Last time, 3 weeks ago, we covered 2D structural analysis of a steel beam section. And just FYI, we did another recording for a composite steel beam section yesterday, so we'll be uploading that pretty soon. So you can reference that on YouTube. I'm going to pass this over to Mike.
All right, thank you so much. I will start to share my screen. Okay, so by way of review, we'll go back and take a look at what we had done before, which was structural analysis and sketchulation. We showed how you make expressions to define the loading first, so the tributary width and then some dead and live load, and then we used the trib width and these pressures to create our linear loads, and then we made a point load, and then we defined linear loads here that we put on our frame element. Frame element was FE was the command to draw a frame element, so we can draw that in there like that. And our restraints, command R for the restraints. Linear loads, LDL. We put those in there, and then we edited them to put in the expressions for our loading. We created load sets, command ls, and we can see what load set they're on by overriding the layers. And we selected one, and we put the paintbrush and applied it to the dead load and the live load to create our model. And then we made our frame element type, FET. And we were just doing a wood beam design. We pushed the new button and we went into NDS and dropped down until we got the shape that we wanted, and then picked out the material that goes along with the shape, and we made our new cross section. This one was a PSL type of beam, and we showed how you can auto create I forgot to mention this, auto create the load sets and the load combinations. So we have load combinations and load sequences. All these things need to be created to run the analysis, but you can use the handy wand wizard button to auto create the load combinations that you want. And of course, you can create custom load combinations with custom load factors if you need those. And then we had all those things assigned, and the model's all ready to run. And we bring in the structural analysis options sidebar, OPS is a command for that. And we see we have the one model, and it's analyzed. We had auto analyze turned on, so whenever I make any changes, the model updates and reanalyzes right away. We can view results in this manner here by checking the box right on top of the frame element that we drew. Or for production sake, we would use the viewport command, viewport model command, in order to automatically batch create a bunch of viewports so that we can look at the results several results all at once, and that's what these are all viewports looking at our basic model with filters for different results that we're interested in each case. And then lastly, we showed how you could tag the frame element. We gave it the tag BM. So if we wanted to do that, lots of ways to edit that, but you can bring up the sidebar here and enter the tag in the modify properties sidebar. And then using that tag, you can query results from the element. The elEnv command gives you an envelope of all load cases within a certain context. So we had the LRFD context, and we looked up the absolute value moment, the maximum one, and then there's also the elRes command, which will allow you to look up the results for a single load combination as opposed to enveloping multiple load combinations. So we can query these results and work with them separately if we need to, and then also just a reminder that if you can't remember what result types there are, what those keywords are, you can bring up the help menu F1 key and start to type frame element, and then you can see all of the different keywords that are available to return whatever result you might be interested in. Okay, I think that's it for the review section here. Any questions on any of that? Anything anybody would like me to go over again?
Hey, Mike, yesterday somebody had asked a great question about if you wanted to take the output from a reaction
Hmm.
from one beam and then apply it to a
Yeah,
girder design. Can you
yeah.
demonstrate that quickly?
Yes. So if you have, let's say, another, let's say this end of the beam is supported by another beam, and we have a reaction here, we could make a little column that goes down to the actual beam that we're interested in, or we could keep the reaction there. It's simply supported, so it's statically determinate, and we can tag that restraint, um, call it R. And now that restraint has a tag that I can reference through the elRes command. So maybe I'll just copy a page over here, um, and then I will make an expression and say that my reaction, call it D, is equal to elRes. So now I'm getting the result from that reaction R for a particular load sequence. Now, you have to be a little careful if you're trying to make another model using the results from a previous model, then you'll want to separate those things into their individual load cases and not use the factored combined loads. So, for example, here we would use just the dead load and the result name. We would want to go look that up and try to remember what those result names are. In this case, I know it's R. And R0 would be the X reaction, and R1 would be the Y reaction. And so now I can see what my reaction is for the dead load case. And now I can make a new frame element, FE. I'm just making something up here. And then I can make a point load, PLD, put it here, and then double click into there and put in R underscore D. And then I want to make sure that I put that on the dead load case, or load set rather. So that's set. And then maybe this element has the same PSL that we used before. And so now this model is ready to run. In fact, I think it probably already has run. You see here, my model 2 is analyzed, and I can view results in exactly the same way as the other things that we've been showing. So, and then of course, if the loading changes or anything about the first model changes, this other model will reanalyze and give us the updated results.
Perfect.
Yeah. Okay. So now moving on to graphing. There is a lot you can do with graphing. I don't think we're going to cover it all in one session here, but we'll get into it and see where we wind up. And if we have more to say, we will say more later. Just close some of the other tutorials here. Okay, so now I have a new file. Let's just talk about the basic concept of graphing. There's two kinds of graphs currently in the program. There's a Cartesian graph or a pie chart. So we're going to start with the Cartesian chart. Command is cht and make a blank chart. Um, so here's my chart. Now within that I want to add a series, and there are a number of series types. We've demonstrated some of these before. Table columns, table grids, cells, expressions, vectors, and single grid. And we'll start with this, probably the easiest thing to start with here is say the expressions. So in this type of series, you're asked for an expression defining x. Let's say we call that x, and an expression defining y, let's call that x squared, and then an independent parameter. So we'll call this x for now, and then I can decide the extents of my graph, and then I can decide using the error tolerances how how much the curve is discretized. So the program internally, once I add the series, you see here it looks like a curve, but it's actually discretized into a number of points. I type EDS, and I bring up the series editor. So now I can edit this series. For example, I can put markers on, and we can see exactly what points it calculated. And the number of points it calculates with an expression graph is dependent on those tolerances you put in. So you can make it more coarse or less coarse as you like. But you see here, this is a parametric sort of a graph. We can make another series, let's say, where we want to draw a circle. Let's say we do it this way. Our expression for x is now, say, the cosine of x. And our expression for y might be the sine of x. And then we leave our independent parameter as x. And then we want to go from, say, 0 to 2 times pi. Now this is going to run through values between 0 and 2 pi. Now we're going to specify this as unitless, although we could specify it if we weren't interested in radians, we could specify it as 360 degrees like that. And we click add, and here is our little circle down there. Now I could have, in order to make this sort of appear with my parabola a little better. Maybe I want to, instead of having this, I could make this 60 sine x. And there you see it's updating as I go along here, and 60 cosine. And that is my circle. Now you might say, well, why is it looking like an ellipse? And that's because the scales aren't equal. But here you have you have just an example of two types of series, and you can see some of the features you have for editing the series. Now, if you want to make the axes look the same, or if you want to adjust other features of the chart, you can bring up the modify properties sidebar. So here is the chart editor. And you can see there's lots of different options. The one that we were maybe just thinking about was the equal scales option. So this forces the axes to have the same scale. And so our circle finally looks like a circle the way we want it. And then there's some other features, drawing the graph border, shading the graph border or not, so you can make it transparent. I'll put this in the white background. So now my graph area is transparent. We'll get to stacking categories in a second. And then there's some other things like masking labels and some other things we'll get to also in a second. And then standard, buttons for adding series, bringing up the entity or the series editor this way, copying series from the series editor. So this is a way that you can select series from another chart and copy it onto this chart. Several features. I'm not going to go deep into all of them. We'll get into block overlay in a second, but you can also add, titles, so that if this is my chart, I could type in here my chart, and then I can give my axis. Oops, yeah, my the issue here is that I'm gonna shade the graph border. Where is my Why is my title not showing up? Hello? That's my text style. Um, for some reason, that's not showing up today. Line. I don't know why my title's not showing up. And that's confusing to me because I do this all the time. And the title shows up. Okay, I'll have to work on take a look at what's going on today with the title. Um, I was editing something with the title recently, and I wonder if that was what I messed that up. But anyway, you can change the axis title. This would be the X axis like that. And this way, I'm actually double clicking into the text rather than going through the sidebar editor. But it's the same thing if I go through the sidebar editor. Um, we go in here and go down and see where it says x-axis. I can call this y-axis, and then that fills it in. We'll look at that chart later after this call is done. You can make the axis logarithmic. Of course, that won't work with negative values. You can change the extents. You can tell the program that the x-axis has dates, so you can work with dates and time in the program. You can set units for the axes, so it'll automatically coerce data in the unit in terms of the units that you specify. And then you can turn off different things like the axis and the grid lines and that sort of thing, and the labels for each individual thing. So it just becomes a very clean and sparse background if that's how you prefer. So those are the various features of the chart that you have to work with, and that's a basic just an example of expression expression series type. Any questions on that? Okay. Now let's say we move on to another type of graph. We'll look at, say, something like this, which is a bar graph. And I have a little example here of some data. Here we have, this is a bending problem. So we have the basic thing. The idea here is that you have a wall with, one, two, three, or four stories. And so the height is getting larger with the number of stories. So it's just proportional to the number of stories. And then, for that wall, this is a wood frame shear wall. We're adding up the components of deflection. So you have deflection due to bending, V times h cubed over EAB, which the A is my boundary size, and the V is going to be my shear per lineal foot. And then you have the contribution due to shear, VH over 1,000 GA. And then you have the contribution due to just an anchorage slip. So these equations are directly out of the NDS. But the point here is that we want to show how you can make this graph that's shown here, and this is a stacking sort of category graph. So here we would make a chart, CHT. I always like to make a page, so I'm working with an actual page, and I've added these um, uh, title page blocks so you now have a title to work with. So I'll make my chart like this. Um, and so then we're going to make a new type of series. We're going to make a table columns type of series like this. Okay, so we select the chart, we type SER to add a series, and here we go to table columns. When we go here, we see there's lots of different options here. We want to select table 2, that's where our data lives. And we're trying to plot on the x-axis, say, the number of stories. And on the y-axis, let's say we want delta. So we select delta, that's the total deflection, and we click add. Okay, so this is the default appearance of our series. You see it's just these 4 points that are in my table. I'll type EDS to now edit this series. I can do a number of things with the series in terms of appearance. For example, I can make it a histogram from the x-axis like this. or I can make it, a step or X or Y, and that's the default. And then there's a histogram from the Y-axis. So we leave that as a histogram for the X-axis. Also, I could do a fill to the X-axis like that. Um, we'll leave it as the histogram for now. Um, I can decide whether I want a line to appear. Now for the histogram series, that's not really relevant, but I can also give it a marker right here. And there's various markers to choose from, and I can set the size. I can decide if I want every point to be highlighted, or I can choose, say, just individual points based on, some logic like the maximum or something. And I can change the size of the markers like that. The description is just going to give a description of this series that will apply to any series type. Gives you a summary of what's going on. And if there were any error with the data, you could see it here. And then I wanted to just show point labels here. So you can add point labels to your series, and then there are a number of special tags that can be included in the series. So for example, X and Y in these brackets will display the X and Y values of the point that is being marked. So I can go here and put, say, Y as my text value and go back, and you see now I have a label for each one of my points. And then you can decide whether you want it, rotated or whatnot. You can decide if you don't really want to have every point labeled, maybe you only want the maximum absolute Y labeled. So this becomes important as you have lots of data. Evenly spaced, frequency of 0, that means every point is going to be labeled. Now there's other things too. For example, I could just take a quick look at some of these other things here. This is for chart tags. We'll get to that maybe if we have time later. But this is what I wanted to show here. I can query the value from a different column in the table, and I can decide if I want a point to appear based on some logic. I can set the color of the points based on a value in the table, and also the saturation. And then I can change the scale of a point based on a value in the table. So I want to demonstrate a few of these features here. So for example, let's look at this one. I just push Control C and copy that and paste it in here. So this is going to be, it's going to come up with the value from a column, and I'm going to give it the column name H. So, and maybe I'll put an actual character Y at H. And so this is now going to tell me 0.42 at 8. And I can put in other things if I know this is in inches. I can put that text there, and I can put this in as feet, like that. So I've got some labels going on here. Then I can also, like I said, I might want to do scale the dots based on what's the value of a particular column. So I put the caret, I type SCL, and then again I give it a column name. This time I'll use delta. So I'm going to scale these. The scale of the dot is going to be the value of the marker. Now you want to be a little bit careful about this. You see this marker here is 0.42 size radius, and then this other one is 2.8. If you have data that's very large, you'll want to provide a scale factor. And here I might want to scale it up a little bit. I can put in a scale factor of say 5, and then that scales up the marker by 5. Now I see I'm starting to cut off at the top, so I'm going to set my maximum value for the y-axis. I just selected the chart and I started to type maximum. And here we have the default value for auto extents was 3.1, but I'm going to put that at 5 and have it show up. Now I see my label is getting cut off there. That's a bit of a bummer. And I also don't necessarily need a legend, so I'll just set the legend location none. And so now everything is kind of showing up. Now you'll notice how I zoom in really close that the points have a mask. They have an outline around them so that they don't get obscured by the grid lines. And you can turn that on and off. That was one of the properties in the chart sidebar right here where it says auto outline labels. And now if I turn that off, you see there's no outline. Turn it back on again, you see the outline shows up. So it's a way of just making sure that things look clear when you present them. And then lastly, let's show some colors here. So I can go into this column. This is a feature of the tables that I can't remember if I've actually demonstrated yet to this group. But we can set contour colors for this column. And we can put in as many color polls as we want. We can make it a hard step if we like. But I'll just do a simple uh, um, contour gradient from 0 to 3 like that. So at 0, we're going to be that gray color. At 3, we're going to be a red color. And you see our the color of the text has matched up with that. And I can also apply those colors to the dots in the similar way to what we've done before. I refer to that column through this color CLR tag, and then the column I want is delta. And now when I click out, you can see I have this gradient of color going on. It only affects the marker color. I have not set it up to affect the bars, so that's something to keep in mind. Maybe a feature we could add in the future. Okay, so here you have an example of how this table column series works. Now, if I double click into this, there are a number of other features that I didn't mention, and I will take a second just to mention some of those. So, in addition to plotting series in the way that we've done, where there's one X column and one Y column, we could have had multiple X columns or multiple Y columns depending on your data. We can also have column pairs, so they could have been several sets of column pairs. We can sort the data on the fly. So let's say I want this to go in descending Y. I can flip it around like that and show the data that way. And then another thing I can do is I can filter, put in a filter expression. Let's say I'm not interested in all the data. I'm only interested in values where H is greater than, maybe H is less than a, or between greater than 8 and less than 24, like that. I can put that in, and we have this one value, 16. It's the only one we have. But that the filter expression is a way of querying data and filtering out what you may not want to see. This is really helpful for large data sets if you're trying to filter things out. Any questions on this so far? No? Okay.
Right.
I will keep moving along. Okay, so then the next thing that we might be interested in if we're studying this problem is the contribution of these various components to the total deflection. So what I might do is I might make a graph of this data. For example, let's see, I'll delete this one and make a new graph, SCR. And now we're going to make 3 series all at once. So another feature of the program is to batch create and batch edit series from multiple charts all at once, and add series to multiple charts all at once. So what we want to do is we want to create 3 series using these delta B, delta V, and delta A columns. So our X value is going to be the same for all of them, but our Y value is going to be multiple. So we check the box multiple, and we do this. So we're going from delta B to delta A, and it's going to make 3 series for us. We could combine the data into a single series, so from 3 columns, but we don't want to do that for our purposes. We just click add here. And here I have my 3 series, and I will make the y-axis auto extents. So I select the chart and start to type auto like that. I say yes. So here are my 3 series. I select them, I make them histograms. And here we have our three series like that. And then maybe for this, I'd like to see the legend. So legend location, say I put that in the default location, which is outside of the chart like that. And so the label, the names of these things are special. You see, the names are all the same, but they're using this special tag, that tag Y, which is referencing the formula used for the Y column. So that's another special tag that allows you to not have to keep track of names so much and do so much typing of names. You have a handy way of seeing this. If I had a filter expression, I could use f there, and I could use x there to get the x function. Or I could put the table name if I wanted to. Or you can do something like this, x versus um, versus y, like that, and work with those tags as you like. I'll leave it as Y. I just want to point that out. So I can see my data here. I can see how they compare. I would put down here stories, and then I would put down over here, double click on that and say deflection. Okay. So that's kind of nice. I see how these three things compare. I see that as the number of stories goes up, my bending takes a greater proportion of their overall deflection. But I might want to see this as a stack of categories, and that's a simple checkbox here. Go into the sidebar editor and stack the categories. So now I see them see the same graphs, but I can see them now in proportion, and I get the total deflection of these various levels, number of stories. Any questions? Okay. From there, I thought I'd demonstrate the pie chart. Um, so the pie chart, you'll draw that with the pie chart command. I just start to type pi, and we draw a rectangle. And I confess this is a little lame. When you draw it up, you can't really see anything. It just tells you that there's no data. You can see it better when you're on the black background, but the pie chart doesn't show anything until you give it some data. So we have to give it some data. And in order to do that, I made a summary table here that queries some of the values from table 2. So let me just go through this. I made a table. Just type TBL like that, table 1. And I made my first component, my first column rather. Oops, I spelled that wrong. Called it component. And this is a text column. So I'm going to put in here these tags, the B, the V, and the A. And if I just put in a B here, it thinks that that might be a symbol, and it's trying to look for the definition of that symbol. I see a question mark. I go over here to the left and I look and see what's the question mark all about. And it says, oh, symbol B is not a constant and has no assigning expression. So then I realize, oh, I meant that to be a text column. I can do that by pushing Control T or right clicking and selecting make a text column. And then I have V and I have A. I don't need these last two, so I pushed Shift Control Delete here. And now I want to get the deflection from each of those components. So how do I do that? What I'm trying to do is get some data from table 2. And so I'm going to use a query. And I'm going to use the query call type of function. So delta in this case is equal to query call. And the table we're looking at is table 2. So query call, if you look at the arguments here, it asks for a query column and a query value. So we want table 2, and we want such that this column H, we're just going to look at H is 32 feet. Or maybe I could do stories is 4. Either way. Stories, comma 4. So now that is going to pull data from I've localized it to a particular row in the table 2. And then lastly, I just need to tell it what is my return column. So my return column is going to be different for each row, and I can do this with text arguments, so I can build this up. So what I want is I have to put in quotes delta, and then the underscore. So I'm referring to the name of a column in table 2, and then I put a plus. That's how you concatenate strings in Sketchulation plus, and then whatever is in the component column. Okay, so now I push enter. Ooh, and I get a question mark. An error. Oh, there's no match. Okay, what's the problem? The problem is that stories for this is a text. This is a text column over here, so that's the problem. So I need to, if I want to do it this way, I have to do a quote like that, and then it pulls out the data, and I can see delta due to B is 1.37 inches, V 0.86 inches, and A 0.75. And so those are the values at the fourth story configuration. So now I need to create an array for the pie chart to read. So I bring up the pie chart sidebar editor, and here's the key thing right here, the expression, and it gives you some hints. You can click the help button, and you can get some help on what you need to do. So its expression has to evaluate to 2-column or 2-row array of ordered pairs of categories and number values. And then optionally, we can add a column for hue, saturation, and luminance to color the pie chart however we like. Otherwise, if we don't specify the colors, we'll just get automatic hues and stuff like that. So what we need here is an expression that defines our data. And that's what we've done here. I'll just recreate that. So we make an expression. I could have typed this. I didn't need to make this expression out here. I could just type it directly into the sidebar editor, but I'm doing it here just to feel nicer to see. pieData 1, I'll make a new variable. And then I use this function table calls, which is the way to get a column of data out of a table. The table we want to refer to is this table 1. Oops, not true. Table 1. And then we give it, I should have written this in the function description, but you can give it a single column or multiple columns separated by commas. So what we want is here component, and we want delta, and it's helping me along. And then that will define my pieData 1. I can push the arrow like this, and I can get that data. There are other ways of getting table data. I'll just point that out. This is the most convenient way to get column data, but you can do the subtable command and provide, say, the table name and subscripts. So, for example, I could get the subscript. It's asking for a row. So let's say I give it row 1, zero-based row, and then the column subscript would be, say, component. And that pulls out the value V. So table 1 V. The reason why you don't normally want to do this, use it this way is because if the table gets sorted, then those indices get mixed up, and so the values will change. So using subtable is a little bit dangerous in that sense. But you can also use this to get an array of subscripts. You could get the component and the delta all at once. So it says a subscript or range of subscripts. So what I could do here is put an array component, comma, delta, and then this gives me that row of data. And of course, I could go here 0, and there's a colon command, a colon operator, and we can put in row bound of table 1. So this is the way to get the same data using array operators, and you can see it's just a little more convenient to use the table calls function to get this array. So now that I have my pie data, I select my pie chart, and I put in the expression pie data 1, and I click out of there, and here is my pie chart. I'm just going to move this off to the side here. Now, the pie chart has a number of features and options, just like the other chart does. I have a title, and let's see if that works. Let's see, we'll call this bending at 4 stories, or rather deflection like that, and see the title works. And we can see these things as percentages. So the chart by default is going to where are the options here? Label, rendering, sort by. No. Yeah, categories. So you have some label options here where you can show the values or not. You can again show a legend if you like and do some shading and things like that. Um, Showing more causes the pie to get smaller. We can turn off the legend if we don't need it. And then you have control over coloring. The hue, the colors vary by hue or saturation or luminance. Sometimes you like to vary them by saturation. Ooh, that's rough. Or by luminance, but they keep the same hue. So if you vary by luminance, you can change the hue, or you can vary by hue and change the saturation. That there's some options there, and the luminance like that to adjust the colors that way. And then if you want to get really fancy, you can make a hue array and send that to the pieData. So let's say I do that. I call this hue, and I just give these numbers, 20, 40, 60. Oops. 60. So those will be hue angles of 20, 40, and 60. And then in my pieData one, I just add the hue column like that. And then now that's getting passed also to the chart. And this is a way you can programmatically control the coloring of your pie chart. Any questions on pie charts? No? Okay. Now I wanted to show another, maybe in a way this is more intuitive. Let's say you have a bunch of data. So I'm going to show some data here. Where the data came from is not particularly important, but I'll tell you it was from a time history analysis. We had 11 earthquakes. So you see there's 11 columns of data. We created a column for the average. So it takes the average of our 11 earthquake values, and then we also have the max. And when we exported this data from Perform, the program that we use for the time history analysis, we exported both interstory drift ratios and deflections. And we also exported data from multiple locations within the floor plan of the building. These three columns here represent the coordinates of those points. So we have the vertical coordinate, so I can see where they are vertically, and then the H1 and H2 would be the X and Y, horizontal coordinates for these, and then we have a node number. And then we also have the deflection and drift reported in two different directions. We have the response 0. We know because we keyed it in this way, the response 0 is going to be drift, and the response 1 is going to be displacement. And then the envelope here would be, normally that would be minimum, maximum. So that if we want to see the positive and negative, positive versus negative. And then we had a hazard column. We ran two hazard levels in this analysis. So it's a big bunch of data. So I wanted to just to show the data. I'll show a couple of things and how we sort this data out, and then we'll show the graphing. So the data that we're actually plotting in or pasting in from the other program is sort of this range here down to the bottom. And let's see, we have, I don't know how many rows of data. It's 575 rows here that we have that we just pasted in from another program. Now we have to know the format of the data in order to fill out these columns, but we're not typing them in one by one. So the first thing I would do when I plot in this data, I know that the data came in with certain order of pasting. So let me just, I'm making a clean table here so I can demonstrate, and I'll recreate these rows. So the first thing I know is that my location, I have two locations or multiple locations per floor. I actually don't know exactly how many locations a priori, so I can show, how do we figure that out? So I deleted those other columns there. What I'm doing here is pushing Shift Control down. I copy these two columns, and then I will make another table here and paste, Control V. And now I want to eliminate all the duplicates. So I push Shift Control down. I've got all the rows in my table selected. And if you see off to the left, I can eliminate duplicate cells with the F10 key as it's written there. So I push F10, and these are the unique locations left in that table. And so what I would do from here is I would say, okay, I have loc 1, 2, and 3. And this would be, say, H1 and H2. And then now in my loc column, I would do this query here. So we want to query that, in this case, the table name was drift locs. And we're using the distance function. So if the distance takes two vectors, in this case, they're 2D vectors, and it finds the distance between these 2 points. So the H1 chord column is in this table, and then the H1 values without the chord, that's in the other table. And so what I did is I found I'm querying for wherever that distance is less than 1, and I want to return the location. And that loc is this column here in this other table. So now I've defined the location. That's all done. So location 1, 3, and 2 is how they're set in there. Now, like I said before, I know I have several columns of data that I need to enter and essentially hand create in order to sort things out a little bit. But I only have to do this once for a given data set, because the building is not changing and I'm not necessarily adding a lot of locations. But it's actually quite quick, you'll see, to put these things in. So my first one, I have direction. I have 1 and 2. And then the second one, I have a response. RESP is what I call that. And that would be 0. Oops. 0 and 1, drift and displacement. And then I have an envelope, that would be minimum and maximum. And then I have my hazard, HAZ, and that's a text column, 1E and 2E, like that. So these are my these are the unique keys for all this data. Now, I when I pasted this in, I have to know what the order is. And I remember this because I've done it a million times. The order went, first it was direction 1, then direction 2, all for response 0. And then we went response 1, direction 2, and then we went envelope, and then we go with the hazard. So what I want to do is start to count these things and divvy them up. I have basically 1, 2, 3, 4 columns here, and each one has 2 possibilities. So I select all these rows, 576. I push F4 because I'm lazy, and I see that it counted the cells for me. That's what F4 does. It counts the cells. 576, and asks if I want to put that in the clipboard, and I say yes. So I put 576 in the clipboard, and then we are going to we're going to now duplicate these cells, 576, and this is a key thing. Do we want to divide by 8 or 4? And I always forget, do I want to do 8, 4, or 16? I think it's 8 because we have these 3 possibilities that go along here. I try this out. I do a lot of guessing and checking. So here what I see is I have direction in 1, and I take a look and see whether I've got these all. I look at the node number. This is 252. I look at this node number, it's 252, and so I can see that that's when the data starts over again. So that covers my direction 1 and direction 2 to start with. The next thing I want to do is my response. So I again do F9 to duplicate, and this time I divide by 4. And then I do the envelope, F9, and this case I divide by 2. And that would take up all of my data, which would mean that I didn't have both hazards in the original data set. Now I think I did have both hazards in the original data set, and I did have 2 envelopes. So then I realized, oh, I didn't quite do all this right. I got to back up 0, 1, 1, and then 2. And in this case, instead of doing this, I do it by 16. Oops, and I need to make sure I clear these guys out like this. Okay, so we back it up again. And this is what happens when I haven't thought through what I'm doing very carefully. But I usually do these guesses and checks to try to make sure that I'm getting things right in the end. So I'm just simply duplicating in each time dividing by a factor less of 2. And the last one is 2. So this is going to cover my whole table. And all I need to do now is just copy these guys down. And it copies, pastes the block in just as you copy it, just like Excel does. Okay, so now I've got my data, and what I've done here with all this column business. I know it's kind of complicated, but it's really just a way of grouping the data so that later on I can query it and get only what I need. Now, for example, if I want to make a chart and plot this, I'll make a page right here, and I'll make a chart like this, and I'll make a series. Now here we go into our table columns type. Oops, my keyboard monitor's hiding the series type. So we type series, and here we have table columns. We want table drift. You can filter the table names if you want by typing in something in the filter field there. So I want table drift 1. That's the one I was just working with. Now is where I get to decide how to sort the information and what exactly I want to print. So let's say, for example, my x-coordinate is going to be, I want to plot all of the earthquakes. So I'm going EQ1 all through EQ11. And then the y-coordinate is going to be my vertical coordinate in the building. So that's a very basic graph that will show me all the earthquake results all at once. Okay, no filtering done at all. Now, this is what we get. We get a bunch of lines, and we see these values are quite large. They're way too large to be interstory drifts. Now, what I should have done was I should have made my series filter for only interstory drift numbers, because I don't want to see deflection and interstory drift on the same graph. The other thing that I should have done is I really don't care to have these as separate series. So what I would do here is select all but one of them, like that. I'll double click on this guy. I can clean this up this way. I select this to say multiple. Now I'm going EQ1 through EQ11 all in one series, and we only want resp equals $0. That means I only want interstory drift values. Okay, and now I have I filtered out all the deflections, and I'm only looking at interstory drift values. And from here, I want to further work with this data. I don't want to see all these lines, because what you see is going on is there's redundant points on every floor level because there's multiple earthquakes that are generating values. There's also multiple locations. So what we will do is just turn off the line like this. And so now we see a cloud of data. That's the spread of our data for all of the earthquakes. Now, maybe I also want to plot the average. So maybe I'll duplicate this series. I right click on it. And there are some options here to replace data, replacing the inputs as I go along, but I'll just do that separately. I double click on this, and now instead of doing multiple columns, I just do a single one, and I click average. We still keep the filter the same, like that. Now, here's where we might want to disambiguate. I'll show you what happens if we don't. So if now we turn the line back on, and we see we have all these averages. Right? That's because, again, we have several locations that we're looking at. We also have the envelope of the plus and minus, so that's one thing we'll have to take into account. And we don't have the several earthquakes anymore, but we do have the several locations and the several directions. So what we call that is we want to disambiguate that information. So what we're going to do is sort ascending Y. And then we want to disambiguate. We want to take just the maximum value. We're still looking at the average values from the earthquakes, but we want the maximum absolute from any given row, or rather, any given elevation. And lastly, I want to only look at the ENV equals $1. That is the positive data. Now, if I also want to see the negative data, I just duplicate the series, and I'll show how this works. We can do a find and replace in formulas. Imagine you could be grabbing many series on many charts all at once and do this type of thing in a batch way. We take this and we replace this with a 0. We click OK. And now I have the average for my positive and my negative values placed on this. Now, for formatting's sake, I would select this and I would just do the lighten macro and then select these and click embolden. And so that's kind of gets you part of the way there to having something that's ready for production. The last thing I'd probably do is go in here and maybe adjust the legend. I tend to not use legends unless I have to, so I would probably turn that off. And what I would do is make a tag chart. And what this is as a label that's going to stick to the series if the series moves, and we would call this average like that. And then I would make another one, enter to repeat the same command, and select this guy and say spread like that. And then on this, I would pick the circle empty, and then I want that scale to be bigger, so I start to type scale, and I click arrow scale and say make that 5. Oop, too big. Enter again to repeat the command. 3, 2, something like that. And so now my chart is getting on the way to being ready for production. So that's all the time we have for today. I did say it was going to be a deep dive. I hope it wasn't too deep. There's still lots more to cover. Some really special features that we haven't gotten to yet. So we'll definitely have a follow-on presentation on this. Any questions before we wrap up?
It's great.
Just a general question. I can
Yes.
see like there are lots of functions and properties
Yes.
and like when I look at the like the help, it's just like general explanation, but like, is there like a manual, kind of a manual with maybe deep explanations of all of that? Because like there may be like lots of functions that I don't even know it can,
Right. Right.
yeah,
Right.
in the software. Like, so how to, or like the other way is just like you have to do like a tutorial for probably everything, right? So that's the only way to
Right.
figure out the capability of the software.
Yeah, we have a conundrum. We struggle with this conundrum. There is a user guide in the help. So that does explain a lot of things. We are always adding features and always improving things, and so sometimes the documentation doesn't keep up, and that's why we're doing these tutorials. Also, like
Mhm.
we feel like sometimes it's really hard to put these things in print and have people understand them. So we're trying to cover many bases. But I appreciate what you're saying. I mean, that aside from we do have lists of these things like the functions list and the operators list that I want you to know about. And then there's the user forum. And then we're doing, like I said, all these tutorials and things. Um, I would like people to open up the dialogue and post things to the forum, which we check. It sends me an email directly, and so we're always getting back on that. We have feature requests, and then it's general topics here and bug reports and stuff. But yeah, there is a lot to learn, and there's always more being added. And I mean, we think it's a really powerful tool, but it does take some time to really grasp how much there is and start to get comfortable.
Thanks.
Any other questions? All right. With that, I will thank you for your time. Really appreciate it. And like I said, please know that we love questions. You're not bugging us at all if you ask them. In fact, it makes our day. And if you've seen anything here that you'd like to know more about, or if we went too fast on any particular thing, we'd love your feedback on that. And hope to see you next time.
Thanks everybody for joining us.